Okay, today we're going to focus on linear inequalities. So a linear inequality is similar to a linear equation. However, you're going to see an inequality symbol. Okay, so what an inequality symbol means is we're going to have more than one answer. Okay, so this would be my linear inequality that I'm given. And I'm going to see which points actually satisfy this solution. So I'm going to recopy that over. And I'm going to try to test my x and my y. So for y, I'm going to have 4. And for my x, I'm going to put in a 7. Okay? So I need to do the order of operations on the right side. So that's going to be negative 14 plus 9, which gives me negative 5. Okay, so what I need to ask myself is 4 bigger than negative 5? Yes, any positive number is bigger than a negative. So this works out, and that would be yes or true. Okay, so you take a moment and go ahead and plug in the other two. You need to pause the video and come back. So I'm going to put a 3 in and a negative 1. So I'm going to ask myself, is 3 bigger than 2 plus 9? And 2 plus 9 would be an 11. So 3 is definitely not bigger than 11. So that would be no. Next, we're going to check the last one. So we're going to put a negative 5 in for y. And so we're asking ourselves if negative 5 is bigger than negative 20 plus 9. Negative 20 plus 9 is negative 11. So would negative 5 be bigger than negative 11? Yes. So that would work out. So the ones here that we got to be yes actually satisfy the inequality. So you're looking for answers that would be true. And there would be a bunch of answers in that region that would become true. So let's take a look if I was to graph that. And you were to graph that on a coordinate plane. And if you remember the other day, we talked about the y-intercept being 9. And I'm just going to put some hash marks to the right and left, a little bit below. So I'm going to go up to 9. And I'm going to fall 2 and run 1. And fall 2 and run 1. Okay, so the line would look something like that. Okay. And then we look for greater than, so that would be the stuff above that line. That means there's lots of ordered pairs above that line. There would be some even down here because that keeps on going. So if you go back to the ones that we said that were true and false, if you look at 7, 4, it would be right there, so it would be in the shaded area. The one we said was false was negative 1, 3. That's not in that area. And then 10 would be somewhere out here, and then negative 5.
The interruption for afternoon announcement. Our volleyball team.
Okay, so you can see there are several answers in that area. So there would be other solutions that would make that system, that inequality, linear inequality, true. Not just, it's not just a line anymore. It's that line and an area. So make sure that you're shading, okay? So what this is talking about, if you want to write this portion down on a separate sheet of paper, it'll probably help you with your work on this. So the first thing when you look, you want to decide if it's got an equal to line under it or not. If it's got an equal to line, that means that your boundary line is going to be solid. Kind of like when we did this a while back with the linear, when we did with the number lines, with the inequalities, that was a closed circle. Now we're looking at a solid line, okay? Now, if it doesn't have the equal to under it, remember we dealt with that with an open circle, and that would be now a dotted line. Okay, so this one's going to be dotted. Now, when you look at the other portion, you're going to have to shade. So when you think about our temperatures, when they're going less than, that means that they're going down. So you would color below that line. When they're greater than, you would color above that line. Now there's going to be a calculator symbol too that you can use on this. And for your calculator symbol, you would pick this little square that's below the line for less than, and the little square that's above the line for greater than. Okay, so in your calculator to do that, you would go to your y equals anytime you want to graph. So I'm going to clear out the other equations, and I'm going to put in this inequality that we were just looking at. So I'm going to put negative 2x plus 9. Okay, now what you have to do is you use your right cursor and you go all the way to the left, and you're going to hit enter till you get to the greater than. So this just means it's kind of a bold line. This would be greater than because that's above the line. So we'll hit graph. So you can see that it's coloring above that line, in which is what we graphed earlier when we graphed that together above. Okay, now if you want to go below the line, you'll go to your y equals and you'll go to the left and you'll hit enter, and that will color below the line. So less than would go below, greater than would go above. Okay, if you remember, we have 4 types of slopes. So if you'll make a little sheet and kind of put the positive on this side and the negative on the other. With a positive slope line, remember that it is increasing. With a negative slope, it is decreasing. Now, if you are coloring for greater than, you would color above, and this is where your y-axis would be above. So if it is greater than, you're going to color above. If it is less than, you're going to color below.
Now for our car riders from B-Wing, we'll have two.
So that would be below.
Car riders from B-Wing, report to the front of school.
So for the negative slope line, this side is where your y-axis is bigger. So that would be above. And this side would be below. So remember, anytime it's greater than, it's above, and less than's below. And this is when you have a negative slope line. The line's going down on the left end, and a positive slope line is going up on the right end. Okay, when you have y equals a number, this is going to give you your horizontal line. And greater than is going to be above, which would be this area, and less than would be below. So this applies with this case and this case. And of course, number 1. Now, when you go to x equals a number, that is your vertical line. And with that one, you cannot shade above or below. So if you have less than, you're going to shade to the left. And if you have greater than, you're going to shade to the right. So this would be left and this would be right in which you would color. Okay, so this is a special case. So you cannot color above or below. So you have to look on your x-axis where those numbers get smaller, and they get smaller to the left, and they get larger to the right. Okay, so I'm just going to leave that here in case you want to maybe take a picture of that before we start the problems. Okay, we're going to go to the very bottom of this page. And if you'll look at the steps right here that are written out for you, this will tell you exactly how to go through each question. So the very first thing is you want to get y by itself. So you want to isolate your y. So if you look in number 1, it's already by itself. So next we're going to graph the line. So you can see step 2, we're going to graph. So we're going to start at -1 on the y-axis. We're going to go up 2 and right 3. Up 2 and right 3. Now you're going to decide if you do a dashed line or a solid line. So this one would be dashed because it's not equal. So we're going to do a dotted or dashed line here. And then lastly, you can see we're going to shade. So you have to decide whether to shade above or below. So since this is less than, the y is below. So we're going to shade below. So this would be the side the y-axis was below. Okay, for number 2, we're going to start at the origin because there's not a y-intercept. And this time we have a negative slope. So remember, we need to make that a fraction for a rise and a run. So this time we're going to fall 4 and run 1. Then I'm going to rise 4 and go left 1. This time the line's going to be solid. And then I look to where I color this time. So I'm looking for where my y-axis is bigger. This is my y-axis. So notice that it's bigger there. So that will tell you that this is the region that we color. Now, if you're ever uncertain, you can always test ordered pairs like we did at the beginning. And any ordered pair in that shaded region would make the inequality true. So if I go back here and I say, well, let's go ahead and test maybe 0, 1, 2, 3, 4. So if I want to test 0, -4, I would put -4 for the y, 0 for the x. That would cancel out. So -4 is less than -1, so I did color the right region. The opposite region would give you a false statement. So one region is true while the other one is false. Okay? Never test a point the line goes directly through. So always pick a point in the region. So if I picked a point here, I could use 1, 1. And therefore, I would ask myself, is 1 bigger than -4? That would be true, so I colored the right region here also. So try to pick easy points if you need to test, but anything in that shaded area should come out to be true. Okay, let's go to a real world example, and we'll see kind of how the inequalities work in this question. So it says John's selling t-shirts. Plain shirts cost $5, and the graphic shirts cost $7. In order to match his product cost, he has to make at least $1,200. So when you want to make at least $1,200, a lot of people see that word less and think it's less than, but that's the least you want to make. So that is going to be a greater than or equal. So I'm going to use P to represent plain shirts. So it's $5 for the plain shirts. It's $7 for the graphic shirts, and we want to make at least $1,200. If he sells 150 plain shirts and 60 graphic shirts, so So this would be like 150 and 60, because P we have here for your $5. Notice that your plane. So we have 150 for the plane. The G stands for your graphic, so we have 60. So I'm going to plug in 5 times 150 plus 7 times 60, and I want to see if that's bigger than or equal to 1200. So we could just type all that in, and that gives us 1170. So that answer would be no. He's not able to cover the cost. Okay, if he sells 90 graphic t-shirts, what's the minimum number of plain shirts to get to the break even? Now, break even means you haven't gained any money or lost any money. So the break even point here is going to be $1,200. Okay, so we have 5P plus, because we need to figure out the number of plain shirts. The graphic shirts we're selling 90. They are 7. So 7 times 90. So that would be 5P plus 630 equals 1200. So 5P equals 570. So he would have to sell 114 plain shirts. If he sold 60 graphics, I'm sorry, if he sold 90 graphics, he would have to sell 114 plain shirts to break even. So if we did 5 times the plain shirts we were selling 114 plus 7 times 90, you see that gives us 1200, which is our break-even point. Okay, going to the back side, the very first thing you want to do is to get it into slope-intercept form. So we're going to move the x. So we'll have 3y is less than or equal to negative 5x plus 12. Remember, put the x in front. Divide by the positive 3. So we have less than or equal to negative 5/3 x plus 4. So we're going to start at positive 4. And we're going to go down 5 and over 3. Down 5, over 3. This boundary line is going to be solid. And when I say boundary line, this line is cutting the coordinate plane into 2 regions. They're called half planes. And you have to understand when it cuts it into those regions, make sure you keep going with that and cut the whole coordinate plane. And when you color, you're going to color one of those areas. So decide which area you're going to color right now. Okay, and for less than, if you look, we need the y's to be less. So here my y's are less. So you would color this whole area that's below that line. And again, you can pick an ordered pair in that region to plug in. But it's impossible to list every ordered pair that works. That's why you do the graphing with the shading. Okay, so we're going to bring over the x. We have negative 6y is less than negative x minus 12. Now we're going to divide by negative 6. Now go back to this part here and pay careful attention to your notes. If you multiply or divide by a negative, don't forget to flip your inequality. Okay, so if you notice right here, we're dividing everything by this negative 6. So that's going to flip. We're going to have positive 1/6 x plus 2. So we're going to start at 2 on the y. Go up 1, right 6. Go down 1, left 6. Then ask yourself, it is a dotted line. Make sure you go through the whole coordinate plane. Are you going to shade above it or below it? So this one would be above for greater. So make sure when you go back to doing your shading that you go to the problem after you have isolated your y. Okay, number 5. So we're going to bring over the x. It makes it a negative. Divide by 12. We do not flip it because that's a positive 12. That reduces to negative 3/4 x minus 5. So we're going to start at negative 5. Go down 3, right 4. Up 3, left 4. So this time we're going to have a solid line. And we're going to shade above. Now highlighters work really good with shading. It's just totally up to you. But you can shade that whole area very quickly. Now the last one deals with your special case. So notice there's not a y. Okay, there's only x and a number. So what you do is you locate this negative 4 on your x-axis. And you have to do a line that goes through negative 4. So the only line that would go through that would be a vertical line because it's got to go through negative 4 all the time. I'm making it dotted because it is not equal to negative 4. And now I'm going to look to where the x's are less than negative 4. The x's to the left are less than negative 4. So we're going to color to the left of that line. Okay, now we're going to finish up looking at 2 word problems. Stephanie spends 10 cents per text message sent and 25 cents per picture message sent on her cell phone. So I'm going to let X be the text message and Y be the picture message. So we've got 10 cents for text message plus 25 cents for pictures. Her monthly budget is $30. Well, that means that she can equal $30, and it'd be nice if she even went below that. So that's the most she can spend would be $30. Okay, so we're going to solve this. So I'm going to bring over the 10 cent. And then we're going to divide by 0.25. And you might want to change that to a fraction. So that would be negative 2/5 after you divide. And then 30 divided by 0.25 would be 120. Okay, if you notice, I've labeled my x-axis, my text, because that's what I let x be. Notice that was my text message. And my y-axis was my picture message. So that's what I labeled my y-axis. Okay, I went by 20s. It's really a scale of 10s, if you notice, but I just kind of labeled the 20s. So that way I could start at 120. So I'm going to start at 120. And then I'm going to go down 2, and right 5. I'm going to connect those. And for less than, we're going to color below. So anything in this area is going to help us answer our question because we want to keep her bill $30 or less. So it says give 2 possible combinations and your answers will vary, okay? I'm just going to randomly pick something. And again, you could pick something different as long as it's in this area. So I'm just going to say 80 text and 40 pictures. That would help her stay within the budget. We could also have, let's say, 40 text, and we'll do 60 pictures. And you can pick whatever you want. Just try to stay within that area, okay? Remember, there's several answers. So we'll look at the last one. Scott makes $12 an hour babysitting. So I'm gonna let that be X. And $8 an hour working at the grocery store. And I just usually just kind of let it become what comes first in the problem. So you can always come over here and put X as babysitting. And Y is the grocery store. Okay, so now we have 12x, 12 times his hours babysitting, plus 8 times his hours at the grocery store. And it says he wants to make at least $600 to get him a computer. So greater than or equal to 600. So we'll go ahead and solve. So we would get 4 goes into that 3/2 x plus, I believe that'll be 75. Okay, go back to your x-axis and make sure that you put that with babysitting, and the y-axis was the grocery store. Now for this one, I've got tens, but then there'll be 5 increments between, okay? So when you look at this line, you would start at 75, and you would go down 3 and over 2. Down 3 and over 2. And for this, we're wanting to buy a computer. So we need to make that or more. So we'd shade above. So again, your answers might vary. I picked 70 hours of babysitting and 0 hours at the grocery store. Okay. You could have 30 hours of babysitting and 35 hours here at the grocery store. So anything in your shaded area would give you greater than. Okay. Now let's say that we pick something on the line. So if I went to 20 and 45, I think that point's on the line right here. So 20 and 45. So if I type that in, I would put the 45 for Y, or I could go back to this one, or you could go to the Y one. It's up to you. I like to go back to that one, the original. So I'm going to do 12 times 20 plus 8 times 45. Uh-oh, I did 80 plus 8 times 45. You see you get 600. So that would work on the line because it equals, because this is a solid line. Okay, that would give them $600, anything on the line. But if you want things more, you would pick the shaded area. So I hope you kind of got your mind back on some of the stuff with your inequalities, and you see how you can use that to think about certain situations in the real world. Don't forget to upload your notes and complete your assignment. Hope you have a great day.